Welcome to Let's Learn by NSK YouTube channel. Mainframe interview questions. Have you ever looked at a green screen on a mainframe and wondered how it all works? It looks like old school computer magic, doesn't it? Well, a lot of that magic comes from something called CICS, which stands for Customer Information Control System. It's a super important piece of software that helps businesses run their daily operations. CICS lets people interact with the mainframe using special screens maps. They're called maps. Not like web pages we use today, much simpler yet incredibly powerful and fast. Think about a form you fill out online, boxes for your name, address, and other fields. CICS screens have something similar. Fields. Each field is a place where you can type information, or the computer can show you information. But how does the computer know how to display each field? How does it know if you can type in a field? How does it make some text brighter than other text? It's not random. It's controlled by a tiny but mighty piece of data. So, we know the attribute byte is important, but what is it really? An attribute byte is a single character of data that sits one space on the screen right before the field it controls. When the CICS program sends a map to the screen, attribute bytes go with it. The terminal reads the attribute byte, it interprets the instructions, then displays the following field according to those rules. You, the user, never actually see the attribute byte. It occupies a position but is invisible, working behind the scenes. The main purpose is to define the characteristics of a data field. Think of it like text properties in a document. Make a word bold, underline a word, change a word's color. The attribute byte does the same for a CICS field. It's the central control for presentation and interaction. Without attribute bytes, every field would look the same. You couldn't tell which fields are editable and which are display only. Every field on a BMS map. The CICS screen template is preceded by one of these bytes. If you have 10 fields, name, account number, balance, you'll have 10 invisible attribute bytes, one per field. This design is efficient. Instead of sending complex instructions per character, the system sends one byte for the whole field. That mattered when memory and CPU were tiny. Let's get into the nitty-gritty of it. Science is all about the details. An attribute byte has 8 bits. We usually number them from 0 to 7. Bit 0, always set the same way. Bit 1, always set the same way. This tells the terminal, this is an attribute byte, not regular data. So, we don't really have to worry about them. The real action starts with bit number 2. Bit 2, the protection bit. If this bit is on, the field is protected. You can't type in it. If it's off, the field is unprotected, and you can enter data. Next up, bits 3 and 4. These two bits work together to control brightness or intensity. At any point in this video, if you feel this video is helpful, please like this video. Normal brightness, standard text, bright, high intensity, makes text stand out for errors or totals. Dark, non-display, you can type but nothing shows, great for passwords. Bit 5 is a must-be bit for a 3270 terminal. We'll skip its deep technical function. Let's jump to bit 6. It's called the numeric shift bit. When this bit is on for an unprotected field, it locks the keyboard into numeric mode. The user can only type numbers, 0 to 9, a minus sign, or a decimal point. It's a simple form of validation to prevent letters in a dollar field. Finally, bit 7, the modified data tag, or MDT. When a field is first displayed, its MDT bit is off, set to 0. If the user types anything, even a character they then delete, the terminal sets the MDT bit on. So, let's review what we've learned about this powerful little byte. The attribute byte is an invisible character that sits at the beginning of every field on a CICS screen. Its job is to tell the terminal how that field should look and behave. It controls whether you can type in a field or not. It controls how bright the text is. It controls whether the keyboard should be locked for numbers only. It's like a set of style rules and permissions all rolled into one. Without it, CICS screens would be a chaotic mess of unformatted text for business apps. By setting 8 tiny bits to 0 or 1, we create specific instructions. Bit 2 controls protection. Can you type here? Bits 3 and 4 control brightness. Mond, normal, bright, invisible. Bit 6 controls the numeric lock, numbers only. Bit 7, the modified data tag, is the clever one. A programmer designs a CICS map and picks the right attribute byte for each field. Title fields, protected and bright. Data entry fields, unprotected and normal intensity. Pin fields, Unprotected but non-display. Entry hidden. You'll never forget CICS attribute bytes after this. Also, please like, share and subscribe to the Let's Learn by NSK YouTube channel.